Hi, everyone. So this is the sixth module for the Bc32 Short Communications assignment. And as you can see, this module is all about the discussion section. So I would contend that the discussion section of a scientific paper is probably the hardest section to write. And I don't mean that it's the hardest section for students to write. I mean, it's the hardest section for everyone to write. Even myself, and I've written several scientific papers over the course of my career, every time I sit down to write a new paper, I always find that the discussion section is the most challenging part to write, and correspondingly, it's also the most time-consuming section to write as well. And when I reflect on what makes the discussion section so difficult to write, I think that it relates to the purpose of the discussion section, because broadly speaking, the purpose of the discussion section is for researchers to provide their interpretation of their experimental findings to their reader. Now, you might say to yourself, well, if I got the exact results that I was expecting when I kind of sat down and conceived of this study, won't that make the discussion really easy to write? Because I can basically just say, well, I got the exact findings that I was expecting. And in your introduction, you probably kind of, hinted at, or perhaps even very explicitly told your reader what results you were predicting to get and why. And so if I got those exact findings, can't I basically just kind of recap what I'd already said in the introduction and then, I'm all done? But the reality is that's not true, because when you get the results you were expecting to get, the expectation now is that you're going to think about how your experimental findings and the conclusions that you've drawn from those findings, how do they connect to kind of the broader research that's been done in that field? One way to think about research is that every research study is a puzzle piece, okay? But a puzzle piece on its own is pretty useless, right? Puzzle pieces are only beneficial in terms of how they relate to other puzzle pieces to allow us to see a bigger, fuller picture of the world. And so when you're writing your discussion section, especially in the case where you got the exact findings that you were expecting to get, much of what you're going to have to do now is talk about how your research findings, your puzzle piece, how does it connect to other research findings? Which of course means you're probably going to have to dive back into the scientific literature to find studies that your experiment connects to. And now the expectation is that you're going to think about, well, how do my findings and all these other findings that I've talked about here, like what are the broader conclusions that we can draw from all of these studies and not just my own? And so again, that can be a challenging thing to do. And in the case where you got results that you were not expecting to get, right, results that were contrary to your predictions, that's obviously going to be hard to deal with, because you already spent all this time, in your mind thinking about, oh, if I get the results that I was expecting, then this is my explanation for why I got those results. Like, you already have a discussion kind of sketched out in your mind as you're carrying out your study. And then when you get results that are not what you expected, it's like you're going back to the drawing board and starting from scratch, because you had in your mind this reason, this really clear reason for why you were expecting to get certain results. And when you end up getting different results than you expected, it means you have to start your thinking, your thought process from scratch, right? And obviously that can be challenging. So what I've learned really about the discussion section is that to write a good discussion section, you have to be an insightful and a thoughtful and a critical and a creative individual, right? And again, these are skills that certainly as a student, we haven't necessarily emphasized those enough within high school and university science courses. Certainly, you're taking this course with me, so you know that I put a lot of emphasis on helping students to build their thinking and reasoning and kind of critical and creative skill sets. So the discussion section of your short communication is an opportunity for you to actually put some of those skills into practice. But even when you become, a practicing scientist, We have to nurture that insightfulness and thoughtfulness and creativity and critical lens in order for us to be able to continue to write effective discussion sections for our scientific papers. Okay, now having said that the discussion section is the most difficult section to write, and I've given you the reasons I think that's the case, what I want to do here in this module is try to provide you with a bit of a formula for how you can go about writing a discussion section in the hopes that this will make writing this section of your short communication a little less of a daunting task. So what I've done is I've identified 8 points that you should definitely address within your discussion section. And so I'm going to walk you through and talk about each of these 8 points in just a moment. But before I dive into these 8 points, I want to talk about something that I think is very important. And that is to say that when you are writing your discussion section, you want to be writing it in paragraph format, with each paragraph kind of, seamlessly flowing into the next paragraph. Okay? You should be writing your discussion section as a coherent whole. Okay? And I emphasize that point because what I've seen students do in the past, and this is why I'm mentioning it, is I've seen students take these 8 points that I'm about to talk about and use them as headings in their discussion section. So they'll write point 1 is this, and then they'll have a little paragraph where they talk about that point, and then they'll say point 2 was this point from the video, and they'll have a little paragraph where they talk about that point, and point 3, and so on. You do not want to be writing your discussion section that way, right? Your discussion section, again, should be written in kind of paragraph format as a coherent whole, one paragraph seamlessly transitioning into the next paragraph, okay? Go and grab any scientific paper that you can find and just flip to the discussion section and kind of read through the discussion section, and you'll get a sense of what I'm talking about. Now, I also want to mention that it's perfectly fine to use headings within your discussion section if you want to, okay? And in fact, a lot of people I talk to say they actually prefer when the big sections of a paper, like the intro or the discussion, are broken up into sections, because scientists have notoriously poor attention spans. So they actually like it when the big sections of a scientific paper are broken down into smaller bits with little headings, and it helps them to be able to kind of digest the material in smaller bites. So absolutely you can use headings within the discussion section. I'm not saying you can't, but those headings should not be these 8 points that I'm about to walk through with you. The headings should be more descriptive headings of what you're talking about in the paragraphs, not these 8 points I'm about to address. So I hope I made myself clear on that point. Okay, so let's dive into these 8 points. So the first thing you should do in your discussion section is you should remind your reader what your research question was. You might be saying to yourself, well, I told my reader what my research question was in the introduction. Why can't they remember it until now? And the reality is that, again, as I mentioned just moments ago, scientists have notoriously poor attention spans, and they also have notoriously short memories. So yes, they read your research question in your introduction, and at that time they remembered what it was, and it probably made good sense to them, hopefully, based on the rest of your introduction. But now they've read your methods, and now they've gone through all your results, and as they're going through your methods and their results, they may actually kind of start to lose sight of what your research question was. So I think it's always a good idea to start your discussion section by reminding your reader what your research question was. And one important point I want to make in this regard is that, here on the screen now, I have one of the research questions that I came up with in one of the previous modules. Does vitamin D intake affect testosterone levels in women? Right here, right now, it's been stated in the form of a question with a question mark at the end. But when we are writing scientific papers, we never actually write our research questions as questions. We always actually write them as statements, typically statements of purpose or statements of objectives or goals. So I might actually begin my discussion section with the following sentence. The purpose of this study was to determine whether vitamin D supplementation increases circulating levels of testosterone in women. So again, that's my research question, but it's written in the form of a purpose statement rather than in the form of a research question. And so not only should you be writing your research questions as purpose statements here in the discussion section, but that's also the way that they should be written in any part of your paper, including the introduction. All right, the second thing you should do in your discussion section is you should tell your reader what the answer to your research question is based on your results. Let me emphasize those 4 words again: based on your results. The reason I'm putting so much emphasis on those 4 words is because what I so commonly see students do when they're writing their discussion sections is they completely ignore their own data. And so they end up writing discussions that are based off of data from previous studies, or they write it based on what they expected the data to be, and they just kind of completely ignore their own data. You never, ever, ever want to be ignoring your own data when you're writing your discussion section. Because again, going back to what I mentioned a bit earlier in this module, the broad purpose of the discussion section is for the researcher to provide their interpretation of their experimental findings to the reader. And so you can't do that if you're ignoring your own findings. Now, why do I think that students often will ignore their own results? I think it's because students have this misconception that their results can be wrong, right? So if you got results that were different than what you were expecting, or if you got results that were different than what previous studies have found, maybe you were doing a bit of a replication of previous studies, and you ended up getting data that are different from what the previous studies had got. When either of those 2 things happen, students seem to just think, oh, my results are wrong, and therefore I better ignore them, and therefore I'll talk about the previous findings or what I expected to find. Here's the thing. Your results can never be wrong. Your results are your results. Now, your results can be invalid if they were collected in an improper way. So thinking about this vitamin D effect on testosterone levels in women, for example, and thinking about how I used HumMod to explore this question, if I know that for all my female patients who were supposed to get vitamin D supplementation, if I know that, oh, I actually did not increase their vitamin D levels, maybe I forgot to turn the supplement for vitamin D on, and it was off the whole time, so they weren't actually getting any additional vitamin D, my results are not wrong, but they are totally invalid because my data points for the vitamin D supplement females, well, they're not actually truly being supplemented with vitamin D. So those are invalid results. If you have invalid results, then you should not even be writing the discussion section of your paper. What you should be doing is going back and rerunning the experiment so you get a set of valid results instead. Okay? So if you have invalid results, you cannot write a discussion section. You can't just say, oh, I'll write the discussion based on what I expected to find or based on what previous studies had found, and I'll just ignore my data because I know that they were collected improperly. No. You can't do that. If you have invalid results, right, data that you know were not collected properly, then you need to be rerunning your experiment to get valid results. But if your results are valid, if you know that you collected them properly, then they are your results. And so now you need to tell me what is the answer to your research question based on your results. Let me give you an example of this. So here is a little bit of data relating to this research question about vitamin D and testosterone in women. So I have a figure here showing plasma testosterone levels in females, some of which got no vitamin D supplementation and some of which did. And I think it's fairly clear from my data points that those women who were given vitamin D supplements, they have higher levels of plasma testosterone than those who were not. And so when it comes to me answering the research question based on my results, I'm going to have a paragraph or a sentence rather like this one show up in my discussion. Given that plasma testosterone levels were higher in women who had taken vitamin D supplements daily for several weeks, it would appear that a chronic increase in vitamin D intake can boost testosterone levels in women. So what you can see here is the second part of that sentence is my answer to my research question, and it's clearly based on my results. Okay? I'm not basing it off previous studies, right? I'm not basing it off what I expected to see. I'm telling you, given the results that I can see, right, that I've got here in this figure, given these results, this is the answer to my research question. And so if you go back to my point number 2, the second part of point number 2 says, be explicit about how your results led to your answer. And that, I think, is what the first part of my sentence did here, right? Because by saying, given what we saw, given this observation, here is my answer to the question. Okay? So that's what you're trying to do here in the discussion section, right? Is after you've reminded the reader what your research question was, you then want to go on to tell them, here is the answer to the research question based on the valid data that I have collected in this study. So again, I want to drive hard home the point. Do not, under any circumstances, ignore your own data. If they are valid data, then they are your results. Tell me what the answer to your research question is based on those results. If they are invalid data, then you should be rerunning your experiment to get a valid set of data, and then write your discussion section where you tell me the answer to the research question based on those valid data. Okay, point number 3, and this kind of connects to point number 2, is explain to your reader whether these results were expected or not. Okay, so again, in my case, I got these results that vitamin D supplementation caused higher plasma testosterone levels in females. So were these results expected or not? Well, let me say that really probably any set of data could be thought of as being both expected or not expected, depending on how you think about it. So I'll start by saying that my findings were actually expected. And here's a sentence I might put in my discussion section related to that. The findings of this study were not surprising, given that similar vitamin D supplementation was found to increase plasma testosterone levels in men. So when I was actually preparing for this study, the first question I asked myself was, can vitamin D supplementation boost plasma testosterone levels in men? But then I actually did my literature search and found, oh, there's already 2 or 3 publications that have addressed that question. So we already know the answer. And it turns out all those studies showed that testosterone does increase in men when given vitamin D supplementation. And so I then discovered that there had been no studies done on women. So that was the reason that I did my research project. But when I found the exact same results in females as we had found previously in males, again, that kind of makes my finding unsurprising, right? Okay, we're seeing that testosterone can be boosted by vitamin D no matter what your sex is, male or female. So in some regards, I would say that my results were expected. But if I actually kind of think a bit more deeply about my research findings, I actually find that I can also think about my research findings as being somewhat unexpected as well. Here's another paragraph that might show up in my discussion section. This one says, despite the prevalence of vitamin D deficiency in both men and women of all ages, and I would have to, of course, have a citation in there for that particular point. I would need to show a paper that talks about how vitamin D is deficient in men and women of all ages. All participants in the present study had adequate levels of vitamin D in their blood plasma at the start of the experiment, right? That's because on HumMod, the participants always begin having sufficient levels of all nutrients and all vitamins and all hormones and everything. So I know that all of my participants in this study, all the females in my study, they had adequate vitamin D in their blood plasma at the start of the experiment. Therefore, it is perhaps surprising that vitamin D supplementation in these women was able to boost their testosterone levels to higher values, because basically we had women who already had normal levels of vitamin D. And so our supplementation was pushing their vitamin D levels into the supra-normal range. And yet we were still seeing an effect of putting more vitamin D into women who already had normal vitamin D levels. So I go on to say here, our findings suggest that normal vitamin D levels are not saturating in terms of their biological effects, which means that a person who has quote unquote normal vitamin D levels, we may actually find that you can still boost those levels to even higher values and you'll still see biological effects as a result. And that actually might be thought of as a bit of a surprising result. You might think to yourself, well, if someone has no vitamin D deficiency, if they have adequate levels of vitamin D in their body, then why would we expect there to be any benefit of supplementing to levels beyond the normal level? So the point I'm trying to make here is that research findings can be both expected and not expected all at the same time. And so it's important, again, as I was talking earlier about being thoughtful and insightful and critical and creative, it's important that we don't just interpret our findings in the simplest and most superficial way. Spend a little time actually reflecting more critically on your research findings, and you may discover that there are some elements to your findings that are unexpected, and you can comment on them in your discussion. Now, going back to the point I was making earlier about sometimes we get data that we didn't expect, right? Because it actually contradicts previous research. Again, that doesn't make our data wrong. And so just to give you a bit of an example of that, so here again, I have my female data with plasma testosterone with and without vitamin D supplementation. But now I've added to it some data that I also collected in this study where we looked at the effect of vitamin D supplementation on plasma testosterone in males. Now, I already said on the previous slide that we know there had already been 2 or 3 studies done looking at vitamin D supplementation in males in terms of its effect on plasma testosterone. And they had all showed that plasma testosterone levels go up in the face of vitamin D supplementation. But look at my data. My data from my study did not show that. My data from my study actually showed that vitamin D supplementation had no effect whatsoever on plasma testosterone levels in males. And so now we have a contradictory finding, right? We now have data that are contradictory to the 2 or 3 studies that we had found in the scientific literature. So again, students will often think that their results must be wrong because they're different than what had been previously found. But again, as long as we know our results were collected properly, they are therefore valid results. And so what we have to do now is we have to spend a little time talking about, well, why do we think that our data differ from what has been previously found in the scientific literature? So how do you do that? Well, here's what I would say. The first thing I would do is I would compare my methods to the methods of those previous studies. And I would look to see if there were any differences. Because if there are differences, those differences might help us to explain why our findings are different from those of previous findings. So for example, maybe I go through the methods and I find that, in my study, I gave these men 250 milligrams of vitamin D per day. And in previous studies, they were giving them 500 milligrams of vitamin D per day. Now, hopefully in my methods, I justified why I gave this lower dose than had been previously done. But the fact that I was giving a lower dose and not seeing a response, this could allow me to talk about the possibility that the testosterone response to vitamin D is dose dependent, for example. And maybe that leads to a future study where, maybe that leads to a future study where we look at trying to figure out the minimum level of vitamin D supplementation that'll boost testosterone levels in males. It could lead to, possible future studies that I could talk about. Maybe I, for example, look at the population of participants that were used. Maybe in my study, I was using all white males, And maybe in the previous studies, they were using males of mixed races, for example. And so maybe I can make predictions that there's some kind of racial component here. We know that, vitamin D supplementation, for example, may have an impact on plasma testosterone in Black men, but not white men, for example, or Hispanic men, but not white men. So the reality here is go through the methods, look at the methodology, look at the participants that are being used in the studies, and wherever you can see differences, focus a little bit of attention on the possibility that those differences could account for why you got a contradictory finding compared to previous findings. And as I also mentioned, you could then transition into talking about possible future studies that could address whether these differences, whether they might be racial or methodological or whatever they happen to be. You could talk about the possibility that future studies should focus on this particular difference that exists between your study and the previous studies, and maybe really explore the impact of that difference in more detail. Now, if you get to the point where you've read the previous studies and you focus on their methods and you cannot see any difference between your methods and the methods of these previous studies, and yet you still have this contradictory finding, now you're probably going to have a sentence like this show up somewhere in your discussion section. You might say, as our results contradict previous findings, despite similarities in methodology, further research on this topic is necessary. So now you're at least saying, look, we have a contradictory finding, but we know that our results are valid. So more work needs to be done to figure out whether it was just that our data sample was a bit of a fluke. And if we do this same study 3 or 4 times over, we're going to get, a different, the previous result is going to be what we're going to get most often. Or maybe we do it 2 or 3 more times and we find that we get no difference with vitamin D supplementation. We can basically say more research is needed on the topic to figure out what is truly going on here. Okay. But usually you're going to end up finding some methodological difference, I would suspect, and that can be what you talk about. But in the case where you can't, then a sentence like this would be sufficient. Okay. Point number 4 is to get more specific. And so that means think about possible underlying mechanisms. So again, we're thinking here about, okay, we've seen vitamin D cause a boost in plasma testosterone levels in females. So the question we now have to ask ourselves is, how exactly does that occur? How is vitamin D causing a boost in testosterone levels in women? So in that regard, what I'll probably start doing is thinking about, well, where does testosterone even come from in females, right? Obviously, when you think about males and you think about testosterone, you think about their testes, right? The testes are the major source of testosterone production in males, but females don't have testes. So where the heck is their testosterone coming from? So I have a little figure here, rather than words, to kind of show where testosterone comes from in females. 20% of it comes from the ovary. So the ovary makes testosterone. Much of that gets converted into estrogen within the ovaries and then released, but some of it gets released without that conversion. 30% comes from the adrenal cortex. And so that's another major source of testosterone in females. And then 50 to 60% comes from the peripheral tissue. And what that basically means is that testosterone precursors that get made, I think both in the ovary and the adrenal gland, these testosterone precursors get picked up by the various tissues of the body, and then the tissues convert them over into testosterone. So these are the 3 major sources of testosterone in females. And of course, I put a nice little figure in here, and I might put this figure in my my short communication as well. But obviously I have to cite the source, right? So I'm just trying to remind you that citations are critically important in a discussion section. So I now know that I know that testosterone can come from these 3 different sources in females. And so one of the things I'm probably going to be asking myself, a couple of questions I'm going to ask myself and then probably talk about in my discussion section is, well, which source of testosterone in females is boosted by vitamin D supplementation, right? So I can talk about the fact that testosterone is coming from these 3 different sources in females. And I don't really know from my own results, because I didn't actually look at anything more than just plasma testosterone levels. So I don't actually know which of these sources was seeing the testosterone. I don't know which of these sources was being boosted by the vitamin D. So I definitely am going to spend a little time talking about these different sources. I'm going to talk about the fact that I don't really know which source was accounting for the increase in testosterone in my study. Could be one of them, could be 2 of them, could be all of them. But I might talk about a future study. I might talk about the fact that, hey, maybe we should look at doing studies where we give vitamin D to, say, rats, female rats, whose ovaries we have removed. Is there still a boost in testosterone in that case? Because if there is, then maybe we're not actually thinking the ovary is an important source here for this additional vitamin D boosted testosterone. Maybe I look at doing studies on female rats where I've taken out the adrenal glands, or maybe I can do work on humans who have had their ovaries or adrenal glands removed for other reasons. I'm obviously not, ethically speaking, I'm not going to be able to do studies where I pull ovaries and adrenal glands out of females just to test and see what's happening with vitamin D. But if I can do this work on rats, I can do this work on females who maybe have already had their ovaries or adrenal glands removed for other reasons. But the idea is that, again, I can pitch a future study here where I say, look, if we want to figure out which sources of testosterone are being boosted by vitamin D, here's how this could be accomplished. Another question I might ask myself is, does vitamin D have any other effects on the adrenal gland and or the ovaries? I left the peripheral tissues out here because that's a little bit of a broader question. But, are there previous studies that have shown that, say, vitamin D can boost the levels of, say, estrogen, which comes from our ovaries? Or are there previous studies showing that vitamin D can boost the levels of cortisol or aldosterone, which are 2 other hormones that come from the adrenal cortex? So again, I'm kind of going into the literature and I'm trying to figure out, broadly, I'm trying to figure out here, I shouldn't say broadly, but specifically, I'm trying to figure out here, where is this testosterone boost coming from? Because I've got these 3 different sources, and I'm trying to plan out some future experiments that could investigate this mechanism in more detail. I'm trying to look at studies that talk about vitamin D having effect on ovaries or adrenal glands and potentially saying, hey, we've seen that vitamin D can boost cortisol levels, which comes from the adrenal gland. Maybe that's why it's also boosting testosterone. Again, it's still me. These are not firm answers to the question by any matter, right? I'm not firmly answering these questions because I don't have experimental data to actually back up these hypotheses that I'm making. But the reality is, again, I can talk about them as good potential future experiments that I could conduct. But I hope you see what I'm getting at here, which is that I want to get a little bit deeper into the possible mechanisms that could explain what I'm seeing going on here. And again, this is going to lead to a number of hypotheses that I could explore or others could explore in future studies. Number 5 is to get more broad. So this is the opposite of number 4. Number 4 was about getting specific, getting down into the underlying mechanisms. Number 5 is about getting broader. And as it says here, think about how your findings fit into the bigger picture. And I already kind of talked a little bit about this at the beginning of the module, right? With my puzzle analogy, that your research is a puzzle piece and you want to talk about how your puzzle piece fits into the bigger puzzle. Talk about the other studies out there that it connects to and what kind of broader conclusions can you draw when you look at your research findings in the light of these other findings. Now, one of the things I'll point out here is that a few years ago, I was reading a paper and it was talking about, they basically had surveyed research supervisors and asked them, what aspects of your students' papers do you find are typically the weakest? And this is actually one of the major things that came up in that survey is a lot of research supervisors said that their students really struggled to think beyond their own research findings. And so I mentioned that only so that you're aware that this is probably going to be one of the hardest parts of the discussion section to write, right? To really think about how does the research that I've done and the conclusions that I've drawn, the answer to my research question that I've come up with, how does that connect to other research papers, and what broader insight do I get from my research by thinking about it in the context of these other research findings? That sounds, just as I'm describing it, it sounds like a really complex task, especially when you think, hey, I'm a third year undergrad, I'm just kind of learning how to write scientific papers. This is a big ask. It is, but of course, this is a group project too. So the hope is that it's not just you by yourself trying to figure this out, but you and your group mates working together to really come up with that bigger picture aspect for your work. So again, thinking about my particular research finding here from this vitamin D testosterone study, here's a couple of questions that come to my mind that could actually help me to write this this broader section of my discussion. Do any other vitamins cause an increase in testosterone in women? So we've seen vitamin D boosting testosterone levels in women. That's what we saw in our study. It'd be interesting to know, have there been any previous studies looking at, say, vitamin A, or vitamin B, or vitamin C, or vitamin E, or vitamin K, and their ability to boost testosterone levels in women? If there have been, great. I can talk about those papers, and we maybe can get some broader insight into, the role of vitamins more broadly in terms of regulating testosterone levels. But even if it turns out there isn't, again, this is an opportunity for me to talk about future directions. Studies should be done with other vitamins to see whether this is a vitamin D specific response, or is this really more of a broader vitamin response that we're seeing with testosterone? Here's another question I could ask myself. Does vitamin D impact the level of any other hormones in women? Right? Again, I could go to the literature and look, are there any studies where vitamin D has boosted estrogen, or boosted cortisol, or boosted thyroid hormones, or whatever, right? And again, if there are, then I can talk about those studies, and I can again perhaps have this broader insight that, vitamin D has this important role in regulating a wide variety of hormones. And I might even start thinking, this kind of connects back to point 4, maybe I start thinking about, what kinds of hormones are these? Are they all sex hormones that vitamin D impacts? Are they all hydrophobic hormones? Like, is there any kind of relationship there? That might allow me to, again, think about the mechanistic way by which vitamin D is having its impacts. And again, if I can't find such studies, again, I can talk about these as good possible future directions. Here's a third question. Has exposure to sunshine been shown to influence sex drive and well-being in women? So we know that vitamin D can actually be produced endogenously within our bodies when we are exposed to the ultraviolet rays from the sun. And we also know that testosterone is hugely important in sex drive and mental well-being in women. So I'm asking this question because it's just kind of a different way of thinking about this vitamin D testosterone relationship in females. And so maybe it turns out that I find some papers published talking about how, women who spend time in nature tend to have a greater sex drive, for example. I could relate that to my finding, and I could say, well, maybe the reason for this kind of nature sex drive boost in females is because the sunshine exposure boosts vitamin D, and vitamin D boosts testosterone, and testosterone boosts sex drive, right? So again, it is challenging to think broader, but I hope I'm giving you a bit of a sense of how you could do that. Okay, so think about, in my case, I'm thinking about other vitamins than just vitamin D. I'm thinking about other hormones than just testosterone. I'm thinking a little bit about, vitamin D in a broader context. I'm thinking about testosterone, maybe in a bit of a broader context. So just try to think beyond just the particular scope of your study for a bit. Try to think a little bit beyond that scope and see how your research connects to, again, that bigger picture. Oh yes, I wanted to emphasize here again, cite your sources, right? So if I do find studies about, say, vitamin B boosting testosterone, I'm obviously citing them. If I do find papers about vitamin D boosting estrogen levels in women, I'm citing that study. If I find a paper that I just talked about where it talks about, sex drive being higher in women who spend time in nature, I'm citing that study. what I'm really trying to drive home here by having these cite your sources come up is that a good discussion is going to have a lot of citations within it. That's how you'll know that you're doing, excuse me, that's how you'll know that you're doing an adequate job with your discussion. If there are lots of citations, it means that you are actually trying to connect your work in various ways to other previous studies. Okay, point number 6 is to talk about the future directions for this research. Now, we have already been talking quite a bit about this already, so this is not something that is coming out of left field. But one thing that I always say to my students is good research will always generate more questions than it does answers. Yes, you start a research project with a specific question and you design an experiment to answer that question, and your data hopefully will provide you with an answer to that question, okay? But the reality is that a whole bunch of new questions should come to your mind once you have the answer to the question that you started with. And so you actually can see that as we've been going through our previous slides here, right? Even if I go back for a second to the slide that we were just talking about, right? These 3 questions that I've come up with here, I mean, these are all questions I started thinking about because of the research that I had done and the findings that I had gotten, right? I started asking questions about what about other vitamins? What about other hormones? What about, sex drive or sunshine exposure? Like all these additional questions that were coming to my mind, they were all stemming from the answer to the question that was the focus of this study. So again, good research generates more questions than answers, okay? And so you want to definitely be talking about possible future studies that you could do that kind of are connected to the research that you've just done. And I'll point out here especially that you have the option anyways to do a second short communication, and you could start with a brand new research question from scratch, but it's also kind of interesting to pick up on one of these future directions that you've talked about in your discussion section and have that be the question that you focus on for short communication 2. Because really that's the way that research works, right? If you are working in a research lab, research labs don't just say, okay, well, here's a random question. We figured out the answer to it. Now let's move on to the next random question. They will always kind of work in that linear way of saying, here's a question that I asked. Here's the answer that I got. That led me to ask this next question. So then I went and did a study for that. Now I get it. In a diverse group, you might want to tackle all kinds of different research topics so that people who have diverse interests all get their interests covered. I understand that. But again, I'm just pointing out that hopefully the research that you do in short communication 1 will give you lots of questions to think about. And one of those questions could be a good candidate for your second short communication. All right, number 7 is to talk about the strengths and limitations of the study. Okay. Strengths and limitations, right? So not just limitations. So I'm actually going to start with strengths first. Strengths I actually find are probably a bit harder to think about, right? But again, when you're thinking about strengths and you're thinking about limitations, it's always going to be centered on the methodology generally, right? What were the strong parts of your methods? What are the weak parts of your methods? Okay. I'll start with strengths here. So here's one example of a strength of my vitamin D testosterone study that I'm going to talk about in my discussion section. It says here, plasma vitamin D levels exhibit a pronounced circadian variation, peaking at midday, likely due to exogenous vitamin D production via solar radiation. Excuse me. And again, I'm going to be citing that source. In the present study, all participants took their vitamin D supplements just prior to sleeping at night. Excuse me. Took their vitamin D supplements just prior to sleeping at night in order to boost vitamin D levels at times when they are usually lowest, and thus supplementation would have its maximal effect. So this was a design choice that I made back in my methods. And I may have even talked in the methods about kind of my rationale for why we were having patients take their vitamin D supplements, maybe at 8 p.m. or 10 p.m. or whenever they're going to go to bed. I may have talked a little bit about this as my rationale for doing that. But here in my discussion section, Excuse me again. Sorry, I have this little tickle in my throat. Here in my discussion section, I'm kind of restating this rationale, but now trying to state it as a strength of the study. Okay. And so, yeah, it's basically an opportunity for me to show my readers that we actually approached this research question in a very thoughtful way, right? We didn't just, give vitamin D supplements and say, take them whenever you feel like taking them. We thought, hey, taking these supplements just before bed so that they can help to keep vitamin D levels high while these people are asleep at night and they're not being exposed to endogenous, they're not experiencing endogenous vitamin D production due to UV exposure, that actually allowed us to maximize our ability to see a boost in testosterone levels because we were maximizing the effectiveness of our supplements. So definitely I'm pitching this as a strength to my study. So really go back through your methods and try to identify one or two kind of choices that you made that you think really make the results of your study great. Really maximized your ability to actually see effects of whatever intervention you were doing. And especially if you find that there have been studies where maybe they haven't done this. If I could continue on this sentence and say, hey, study X from, 2020, they also looked at vitamin D supplementation and its effect on testosterone levels, but the patients there were allowed to consume their vitamin D supplements at the hour of their choosing. And that may have introduced variability in terms of the effectiveness of those vitamin D supplements that masked their ability to see how testosterone was affected in those females, right? I mean, if I've seen previous studies doing things that I think are going to actually make their study less impactful in some way, and in my own study I've corrected that problem, then I really want to kind of highlight that strength, right? Highlight the thoughtfulness that I put into designing my experiment. Now let's focus on limitations. Now, with respect to limitations, one of the things you should immediately think about are the ambiguities in design choices that we talked about back in the study design module, right? We said that ideally we're trying to eliminate ambiguities, right, by our design. And of course, we have to justify our design choices. But the reality is that, again, in the method section, we're going to be kind of talking about, ambiguities and design choices kind of in a let's rationalize them kind of way. But in our discussion section, we're going to talk about them now as potential limitations where we couldn't avoid ambiguities or where we made design choices and we want to reflect on what impact those design choices may have had on our experimental findings. So I'll give you one example here. This relates to an ambiguity in my vitamin D testosterone female study. I've written here that previous studies have shown that vitamin D absorption is lower in elderly females. Given that the average age of females used in the present study was 40, perhaps our findings overestimate the impact of vitamin D supplementation on elderly women. So again, we made a design choice in our study to just have women of all ages be involved in the study. We would give them all supplements and we would see what impact it had on their testosterone levels. Overall, we saw that there was a significant increase in plasma testosterone in those women given vitamin D. But we do, in the back of our minds, wonder, is it possible that that difference is being driven mostly by the effect that vitamin D had on younger women? And maybe some of the older women in our study weren't seeing as big a testosterone jump because they weren't absorbing the vitamin D as well. And so again, maybe we're overestimating the impact that vitamin D could have on elderly females. So again, when you think about our study design, I mean, there's two ways we could have designed our study. We could have said in our study, we're going to just pick a particular age of females and do the study on those females. So maybe we say, hey, you know what we're going to do? We're going to take 20-year-old females and that's it. And we're going to give them vitamin D. We're going to see if it boosts their testosterone. And it did. Okay, let's say it did. Now, obviously, the ambiguity that we're stuck with is Well, we know it works for 20-year-olds, but we have no idea if it works for 30 or 40 or 50 or 60 or 70 or 80-year-olds. So we still have an ambiguity. Of course, another way I suppose we could have designed our study is the way we did, where we just took women of all ages and just treated them as one homogeneous group, women, and we looked to see, did vitamin D supplementation have an impact on these females in terms of their plasma testosterone? And we saw that it did, but now we're left with this question, well, is the impact equal across all age ranges? We don't really know. So kind of either way, we have an ambiguity. So we have to address that in our discussion. Now, you could be saying in the back of your mind, well, could we not have designed a study where we had like huge numbers of females, lots of 20-year-olds, lots of 30-year-olds, lots of 40-year-olds, lots of 50-year-olds, lots of 60s and 70s and 80s, and we'll give them all vitamin D supplementation, and we'll look to see if the vitamin D is boosting testosterone at all different age groups? Absolutely, we could have done that as well. Maybe that would be a way for us to overcome these ambiguities that we currently have in our study design. Probably the reason that we didn't do that was because of how that would be a huge sample size, right? So maybe that was our limitation, that, we could only enroll, again, even when you're thinking about doing HumMod, can you really do, 100 simulations because you want to have females from all these different age ranges? So there may have been a bit of a practical limitation that we could talk about there in terms of saying, look, we could have designed our experiment in that way, but it would have meant having hundreds of women enrolled in our study, and we were a bit concerned about being able to find enough females of all these different ages to actually complete that study or whatever. So again, I'm kind of acknowledging here that my design has this ambiguity and this limitation. Again, I could almost pitch my current study as a preliminary study if I wanted to, and say, now that we know that there is this vitamin D boost, we want to go in and explore whether that boost occurs in elderly females specifically, because we know that they don't absorb vitamin D as well. And then we repeat the study with 80-year-old females instead. So again, I hope you get a sense of what I'm talking about here in terms of how I have addressed a limitation, but again, I can also spin that limitation into a future study that we could do. Again, emphasizing citing your sources here. So it said right here, previous studies have shown that vitamin D absorption is lower in elderly females. Obviously, there should be a citation there to prove that point. Another category of limitations that you could consider is limitations that are imposed upon you by HumMod, right? So HumMod can do a lot of things, as we know, but there's also a lot of things it can't do. So sometimes your limitations are imposed upon you by HumMod. Now, I do want to emphasize, and I think I emphasized this a little bit in the study design module, you're always going to have limitations in scientific research, right? I mean, HumMod's limitations, I actually think that they are a good thing in some way because they mimic the kinds of limitations that you might face in a real research lab. You might go into a real research lab and say, well, I want to do X, Y, and Z to try and answer this question. And your research supervisor says, well, we have the tools to do X, but we don't have the tools to do Y and Z. And so you run your study with just X and you can't do Y and Z. And so now you're left again with some maybe lack of information that would be really helpful to you, but you just don't have the capacity to do those studies. So again, limitations exist not just in HumMod, but in the real science research lab as well. So again, just as an example here of a HumMod imposed limitation for my vitamin D testosterone in females study, it says we were only able to measure total testosterone in the blood plasma, yet free testosterone levels are what determine the biological action of this hormone. So again, in HumMod, when you measure testosterone levels, it's only total testosterone that you measure. But testosterone actually exists in the blood plasma in two forms. There's the free testosterone that can actually bind to testosterone receptors and exert biological actions on the body. And then there's also what we call the bound testosterone, which is bound up to various testosterone carrying proteins within the blood plasma. Those testosterones that are bound to the protein actually cannot exert any kind of physiological action at the moment on the body. So again, we might see testosterone levels being boosted by vitamin D, but we don't know whether that boost is free testosterone. Is it bound testosterone? Is it both? Is this testosterone boost therefore going to actually have any physiological action on the body? We don't really know. So again, that's a limitation of our study, but it was a limitation that we couldn't get around with the tools that we had. And again, just pointing back to the real research lab, real research labs oftentimes do just measure total hormone levels because it's way easier and way cheaper, right? Measuring free hormone levels is a lot more technically demanding and expensive. So you might not necessarily have the technical know-how or the financial resources to actually be able to get that resolution in your data. So again, the HuMMOD limitations are mimicked really by real kinds of limitations that you can experience in research labs. So again, the important point here overall is to spend a little time as you're writing your discussion, thinking about what aspects of your methods are strong and really allow you to make a powerful conclusion from your data, and what aspects of your methodology maybe impose some limitations or leave you with some ambiguities, and again, address those as well in your discussion. Point number 8, which is actually not something you have to do, but something you should avoid doing in your discussion, is don't feel compelled to explain every little detail from your results. Keep your discussion focused on your research question. And that is especially important, I would say, when you're writing a short communication, because you're limited in terms of your word count, right? I mean, a short communication is meant to be concise and brief. So don't try to explain every little detail from your results. Keep focused on those aspects of your results that are relevant to your research question. And so as an example of this, here's my data set again, plasma testosterone levels in females with and without vitamin D supplementation. You actually see here that there is a bimodal distribution in both groups. That is to say, some of the females have distinctly lower levels of plasma testosterone than others. So yes, there's a bimodal distribution that exists within my data set, okay? But the reality is that doesn't actually matter to my research question, because my research question was not about, variation in testosterone levels among females. It was about, does vitamin D supplementation boost plasma testosterone or not? And I can see that despite the bimodal distribution here, generally we're always seeing an increase in plasma testosterone in the vitamin D supplemented individuals. So again, I don't really necessarily want to spend a lot of time in my discussion section talking about this bimodal distribution. I could maybe dedicate a sentence or two to it just to say, yes, we noticed there was a bimodal distribution. This hasn't been seen previously, or maybe it has been seen previously. So then I can just refer people to papers that already talk about this bimodal distribution. If it hasn't been seen previously, maybe a quick sentence about, we don't know what the underlying cause is. Could be an interesting thing to focus on in the future, but don't spend a lot of time talking about this detail because it's not relevant to your research question. Okay. So again, you could mention it, and we've said this a lot throughout this module today, is we can take a lot of these limitations, we can take a lot of these unexpected results, whatever, we can take a lot of these things and spin them into possible future directions. And this again relates to that idea I mentioned about how good research will generally create more questions than it does answers. We've talked just in this little module on this fake study about testosterone and vitamin D in females. We've actually come up with all kinds of possible future studies that we could explore. So we've got all kinds of additional questions that we could explore in future short communications just from this little fake data set that I've been talking about here. Okay, so that brings us to the end of this module. And so what are we submitting for this module? Well, for this module, you are obviously submitting the discussion section of your first short communication. And so the way you're going to write your discussion is by kind of following the 7 do's, and I guess that one don't at the end for writing your discussion, right? So restate your research question, give the answer to the question based on the data that you collected, discuss whether your results were expected or unexpected, get more specific by thinking about how mechanistically you could explain your results, get more broad by thinking about how your results connect to other studies and what kind of broader conclusions your study together with those other studies can lead to. Talk about future studies that could be done. Definitely address the strengths and limitations of your methodology. And as I said, the don't here is don't explain every little detail. Just keep your discussion focused largely on the research question at hand. As I already mentioned before, your discussion section should be written in a paragraph format without headings. And when I say without headings, I mean don't use my points 1 to 8 here as your headings. I said already, you could have headings that just help to kind of break things up a bit if you want, but don't use these 8 points as headings. That's the point I'm trying to make. I say here, make sure you're citing at least 3 to 4 papers. You'll probably be citing more, but I really want to emphasize here that a good discussion section should be well cited. Okay, so we're going to be looking for that. We're going to be looking to make sure that you are citing a lot of papers within your discussion to show us that you are, again, comparing your findings to previous studies, for example. And as for all the modules, once you submit it, the TAs will evaluate your work and they will either approve it. And of course, in this case, if they approve it, then you are done your first short communications. So congratulations on that. If they reject it, of course, as they always do, they'll provide you with an extensive amount of feedback so that you can revise and resubmit. Okay? So with that, I will stop talking. I hope that I have made you feel a little bit more confident and comfortable as you sit down to write your discussion section to this short communication. And I look forward to reading it. So take care.